Good morning, everyone. Thanks for jumping on. My name is Zach Allison with ATS. I'm our National Accounts Manager, working with engineers, architects, interior designers, and even design build contractors all across the US and Canada, helping them get set up on the ATS spec tool. Part of that spec tool is primarily focused on ensuring accurate configuration and selection of everything from the faucets and flush valves that we'll discuss today to water heaters, pumps, some HVAC equipment, drainage, really trying to touch as many of the applications as we can and help all attendees make accurate selections that are truly configured to your project's requirements. We try to make it quick and easy to access all of our manufacturers' product information, and we do have, I think, about 40 to 50 now different manufacturers that are available on the spec tools. One of the additional elements that we provide is, training, lunch and learns for your firm, as well as these ATS University sessions, which we've been hosting for years, providing, whether it be application-based deep dives like today, where we're talking about healthcare in general, to product-specific or feature-specific deep dives on, new elements of, say, a faucet, or we did one the other day on the water conservation. Available now from all the Delta products. So similar to your internal lunch and learns that you probably have, and any of the topics that we cover, we can certainly provide lunch and learns directly for your firm as well if you want to go a little bit deeper. We do record all of our sessions, and I'm going to pop it into the chat here so that everyone can access any of the previously recorded sessions. And of course, this is going to be an ASPE accredited presentation. You should have already received a CEU events registration link, but not to worry if you don't have it set up now. As part of our follow-up, we'll be ensured to help you with your self-reporting and sending out our typical certificates of attendance. With all that housekeeping being kind of said here, I want to thank our partners over at Masco and Delta for joining us again. And Ranveer, you're becoming a frequent guest here at ATS University. Thanks for jumping on and joining us again.
Absolutely. All right. Thank you, Zach. Thank you everyone for joining us for this session. This session is going to be focusing on healthcare trends and specifically on the plumbing fixture side of things. As Zach mentioned, if you do need a certificate of attendance or confirmation after the fact, please do reach out and make sure that you get your credits, and we can help you with that either through CEU events or just providing that certificate for yourself reporting. So let's talk a little bit about this course. So this CEU course is going to discuss the unique characteristics of healthcare facilities and how to select plumbing products that are right for the chosen application and designed to withstand the stringent environments in healthcare. There are 5 learning objectives for this course. So the first part of the course, you'll understand the vastness of healthcare facilities. In the second part, we'll discuss industry standards related to plumbing products in the healthcare industry. In part 3, we'll talk about various types of products that can affect the healthcare plumbing environment and keys to keeping it safe. And then in part 4, we'll discuss sustainability trends. And finally, in part 5, we'll talk a little bit about plumbing maintenance in healthcare facilities. So let's start with taking a look at types of healthcare buildings. So there are many types of healthcare facilities, from simple to complex, from a plumbing perspective at least. These include buildings, portions of buildings, or mobile enclosures in which medical, dental, behavioral, nursing, obstetrical, or surgical care is provided. In all cases, you, the engineer or specifier, should work alongside the designer, architect, and facilities team to ensure you understand the requirements of the facility and any special needs that should be considered. Where facilities such as clinic and medical offices are more straightforward in their plumbing needs, a facility such as a hospital is like many healthcare operations inside one overall structure, so it's considered more complex. As an engineer, you have 3 primary customers in a healthcare scenario: the owner of the building and the 2 users, which are the staff and the patients. All of their needs should be taken into consideration when specifying plumbing products. And it's not surprising that cost is often a key consideration when it comes to specifying commercial products. but the true cost reaches far beyond the initial purchase price. When you're looking at fixtures for a space, it pays for specifiers, architects, designers, and contractors to consider the total cost of ownership or lifetime cost of a product to make the most informed decision. Anything that's purchased in quantity, such as faucets and fixtures, are viable candidates for cost of ownership consideration. To create well-functioning buildings and also be efficient for those who own them, decision makers such as yourselves have to weigh lifetime value when making these purchases. So the total cost of ownership is especially important when choosing plumbing fixtures since these products are used multiple times a day on a daily basis. Now, when it comes to plumbing, all costs, direct and indirect, are incurred throughout the life cycle of a product and should be considered. So you have durability, you have how reliable it is, the ease of installation, the required maintenance, such as repair parts and associated labor, the frequency of replacement, the product efficiency, infection control, and sustainability. The cost for a hospital to shut down a room for repair can vary depending on several factors, including the type of repair needed, the size of the room, and the location in the hospital. But the labor and materials aside, there can be added complications. So, for example, you have downtime. When a room's shut down for repair, it can't be used for patient care. This results in lost revenue for the hospital. The longer the room remains closed, the greater the financial impact. Then you have patient displacement. If the room's being repaired, if it's typically used for patient care, the hospital may need to transfer patients to other rooms. This can disrupt not just patient care, but it also increases the administrative workload of the hospital. Next, you have infection control measures. So hospitals have to follow strict infection control protocols during repairs. This may involve additional cleaning, testing, and monitoring to ensure patient safety. And finally, temporary relocation of services. So if the room provides specialized services such as an operating room or ICU, the hospital may need to temporarily relocate those services to other areas or even other hospitals, which of course can be very costly. So just an interesting estimate, according to the Canadian Institute for Health Information, the average cost of an inpatient stay in an acute care facility varies by province and year. For example, in Alberta during 2021 to 2022, the estimated cost of a standard hospital stay was about $9,000. The specific repair costs for shutting down a room would depend on the nature of the repair and the hospital's internal processes, but that's just a I guess a key point in pointing out just how costly it could be to shut down a room in a hospital. Now, it's critically important to ensure that all buildings and plumbing codes are adhered to, whether the healthcare facility is a new build or a renovation project. Throughout North America, we typically enter a hospital, doctor's office, or medical clinic without concern for our safety or well-being. We expect that the design and construction are safe, and that protocols have been adhered to, keeping the facility clean and safe. Because of the existence of healthcare building and plumbing codes and standards, we're right to expect that our healthcare facilities are safe. While these codes and standards have several objectives, their primary goal is to protect public health, safety, and well-being as it relates to the construction and ongoing occupancy of buildings. So let's start with the US. In the US, compliance with all state and local building codes is mandatory on all projects. For healthcare projects, the complexity increases exponentially. State health and department codes and federal Centers for Medicare and Medicaid Services requirements are vital to the ability of a healthcare facility to be accredited. This adds another level of AHJ or authority having jurisdiction to review to your project. HIPAA regulations address security and privacy of protected health information. This regulation also highlights acoustic and visual privacy. The ADA, or the American with Disabilities Act, applies to all public facilities and greatly impacts building design and its general and specific accessibility requirements. It's also important to understand owner guidelines because they're becoming increasingly rigorous as hospital systems merge and build outpatient facilities types that are less familiar to them. So they're going into newer types of facilities. Additionally, energy codes continue to get more stringent, necessitating owner education and budgeting to implement. In Canada, it's a little bit different. but very similar. One of the primary considerations is the need to comply with strict regulations and standards set by governing bodies such as Health Canada at the federal level and provincial health authorities, which are the primary administrative bodies of healthcare in Canada. Each province has its own building codes and regulations that also have to be followed. These regulations cover various aspects, including building codes, infection control, accessibility, and patient privacy and safety. Compliance with medical building standards is paramount to ensuring the safety, functionality, and regulatory adherence of healthcare facilities in Canada. Provincial health ministries or departments oversee the implementation of these regulations to ensure that healthcare facilities meet the safety and quality standards. So let's talk a little bit about codes versus standards and the bodies who govern them. In order to sell products, they must meet the laws and regulations where they're being offered for sale and installed. So not where they're coming from or who the manufacturer is, but where they're being offered for sale and physically being installed. So some of the governing bodies you're likely aware of are standard development organizations. So these are the authors of performance standards that may be adopted in codes and regulations. So you have ASME, CSA, IAPMO, NSF, UL, and the likes. Next, we have SDO accreditors. These are the ones that actually make sure that you're meeting the standards developed by those standard development organizations. So these could be ANSI, SCC. And then the law is the plumbing code adopted by a province or state and city bylaws. To simplify the code, it references several standards like the harmonized ASME A112 or the CSA B125 plumbing supply fittings. Because the standards are referenced in the code, they become the law. So just because they're not specifically calling out all the requirements um, of one of these standards, such as CSA B125 or ASME 112, doesn't mean that they are not the law. Just referencing one of these standards in the law makes it part of that law or that code. So one way of looking at the differences between codes and standards is that a code tells you what you need to do, and a standard tells you how to do it. So a code may say that a building has to have tempered water. The standard will spell out what kind of system and how it works. So these are just some of the regulations, industry standards, and codes that affect plumbing products in commercial buildings. So over on the left side, you have provincial, state, and federal regulations. So these regulate anything from, for example, the Department of Energy for efficiency, Safe Drinking Water Act for lead levels, all the way down to the more recent ones at the bottom, such as PFAS. And then in the middle there, you have industry standards. So these are not regulations set by government, but these are industry standards set by the industrial, I guess, the companies and the players in that industry. So these may be ASME standards. They could be NSF, ANSI, or the UL. And then you have building and plumbing codes. These are codes written again, usually by some level of government with participation from industry. So these could be IPC, UPC, NPC, or in California, Cal Green. So in the United States, the FGI guidelines for design and construction are widely recognized standards for planning, designing, and constructing healthcare facilities. Many federal agencies and states use these three as either a code or a reference standard when reviewing or licensing healthcare facilities. The intent of all three of these documents is to enhance the quality of healthcare while protecting patients and staff. The guidelines documents consolidate minimum program, space, risk assessment, infection prevention, architectural details, surface, built-in furnishing, and building system requirements in one convenient place. So states and federal agencies use the guidelines to regulate new construction and major renovations of health and residential care facilities. In Canada, in addition to national and provincial building codes, healthcare construction is generally guided by standards such as those provided by the CSA Group or the Canadian Standards Association. One example is Z8000-18. So the Z8000 is a standard. The -18 refers to the revision, which is 2018. And this outlines requirements for the planning, design, and construction of healthcare facilities. So CSA Z8000 promotes best practices in infection control and prevention throughout all stages of planning, design, and construction to create healing environments where healthcare-associated infections are reduced and better patient outcomes are supported. The CSA Z8000 standard, surprisingly, is not mandatory in Canada, but it is widely adopted by many accredited hospitals and healthcare facilities as a best practice. Also, CSA Z317.1-16, so that's the 317.1 standard, titled Special Requirements for Plumbing Installations in Healthcare Facilities, outlines the specific requirements for plumbing systems in healthcare settings. This standard covers aspects related to the design, construction, operation, and maintenance of these systems to ensure that they meet the unique requirements of healthcare facilities. For those on the call that are going to be working with healthcare facilities design, even if you are in the US, the Z317.1 is an excellent standard to read up on, just because it provides usually the best in class and best practices. So those usually do make themselves into, for example, the FGI guidelines. So some Canadian healthcare facilities and design professionals also do refer to the FGI guidelines for additional insights or best practices, especially when working on projects that have cross-border considerations or when seeking to align with international standards. So as you can see, a lot of these standards and guidelines, they overlap, they share information. A lot of them will have common elements because generally speaking, we're all moving towards the same type of, infection control, minimizing infections in healthcare facilities. So depending on the type of project, not all codes and standards may be created equally, especially in the case of a healthcare facility. For example, some local jurisdictions have made compliance with the water sense program mandatory within the building code. However, these requirements may be in direct opposition to infection control requirements in hospitals. Meeting codes and standards requires early and open communication channels between the project team, owner, and the AHJ. That's the authority having jurisdiction. So this is an organization, agency, or individual responsible for enforcing codes, standards, and regulations related to building construction, fire prevention, and life safety. Um, and you should be really consulting with them right at the start of the project. It's critical to find out which standards and design guidelines need to be applied and ensure a complete understanding of the expectations. To ensure a smooth process, preliminary meetings with the AHJ and other stakeholders are recommended. In a previous talk about this specific topic, I had the question of what is an AHJ, and I know many of them on the call will already have an understanding of this, but an authority having jurisdiction is basically either an organization or an individual that's responsible to not just guide how you do your work, such as, one example might be the electrical authority, but it's also the ones who are going to do the inspections after the fact. So these people should be consulted right at the start of your project to make sure that if there are competing codes or guidelines or requirements, that you are clear on which ones you need to follow. So then there's product certification, which needs to be visible on the plumbing products that you select for your installation. So these could be CSA, WaterSense, or IATMO. And these basically, they are logos that can be placed on products that meet the certification of the specific requirement that you're trying to fulfill. So now let's move on to products. So it's important to have clarity around what is and is not important in each type of healthcare area and the room that you're specifying for. So charting out the need to haves and nice to haves is a great starting point so that when you're selecting products, you can be sure their functionality will meet the goals. The needs of a lab may be vastly different from an operating room or a patient room. Plumbing inside healthcare facilities tend to be much more complex than your everyday office building, for example, because hospitals and other medical facilities have unique systems not found anywhere else, including medical gas, dialysis systems, emergency showers, eye washes, clean rooms, laboratories, and operating rooms. It tends to reason that there are many considerations engineers must think about when it comes to designing plumbing systems in healthcare applications. The most critical consideration in designing plumbing systems in healthcare facilities is patient and staff safety. The delivery of clean and safe potable water is paramount, and accounting for all the design elements necessary to do that is critical. Ensuring clean and safe potable water includes using materials that will not include contaminants into the water, as well as a system designed to deliver water at safe temperatures and essentially free of harmful bacteria. Other important considerations include prevention of scalding and thermal shock. Engineers and designers should take a systems approach when specifying plumbing solutions, thinking through how the water will get through the water supply pipe, through the faucet or flush valves, and then safely down the drain as well. So, 4 keys to efficient plumbing design in healthcare environments. Because of the sensitivity of the healthcare environment and the importance of water to a hospital's patient care mission, there are many unique requirements that facilities professionals have to consider when designing a healthcare plumbing system. They include accessibility, so keeping plumbing equipment easily accessible is critical to maintaining it over time. For example, keeping pressure reducing valves in accessible spaces will minimize disruption to patients and hospital staff, and will help to ensure that regular maintenance is performed as required. Maintainability. So maintenance as well as capital investments have to be considered prior to the design of the plumbing systems. For example, the team should do their homework when selecting battery power faucets instead of the typical hardwire faucets. After doing the calculations, an engineering team may determine that the hospital would have to hire an additional maintenance person just to change out the batteries for a hospital's faucet. Redundancy. So anticipating potential shutdowns of equipment and making sure there's access to backup products and systems when part or all of the system needs to be shut down. And then serviceability to make sure that the location for centralized systems are in areas that are easy for maintenance staff to access and don't require trips through areas such as a sterile corridor. So the faucet and fixture work as a system. It's important that you understand the unique aspects of the vast assortment you can specify from to ensure the two work in unison to meet your project's needs. To do that, it's a good idea to make a list of what you need the products to accomplish for your project and a good understanding of the functions available today in both faucets and fixtures when combined uh, to ensure that you'll meet your project goals. So what's paramount for this job or this particular room? Is it hygiene? Is there a particular flow or temperature that's required? So on. So some of the top aspects include heavier construction when we're talking about commercial products. So for example, this could be thicker walls. In the case of a faucet, it could be a fully cast brass faucet instead of clamshell design. They need to be designed for universal use with people of all physical abilities considered. Thought put into how and with what it would be cleaned. So smooth surfaces to prevent bacteria growth, no crevices. Tested to perform to higher levels of physical stress. So anti-rotation pins, vandal-resistant screws. Flexible to a changing environment. For example, adjustable flush volume on a flush valve where pressure might vary between one patient room to the next or between one floor and the next. Thought put into how to reduce installation time and effort. So pre-plumbed mixing valve assemblies. Thought put into how easy the product will be for facility staff to maintain. So that could be, for example, offering repair parts instead of repair assemblies. A 10-cent washer is a lot cheaper to buy than a full a cartridge, for example. And then the thought put into the need for a variety of faucet flow rates from 0.35 to 2.2 gallons per minute, which are the industry standards. So inside of a medical facility, such as a hospital, there's going to be a range of needs and therefore a range of products that should be considered depending on the area of the building and the specific application. But first and foremost, user safety and well-being have to be considered. So germ transfer is something on most people's minds when in medical facilities. One approach to reducing the need to touch plumbing surfaces is to select hands-free faucets and flush valves in the space where it makes sense. Different factors such as budget, accessibility needs, the nature of the user, how water needs to be delivered, and water usage control contribute to the ultimate answer. If you decide to go with an electronic faucet in your project, there are three sensing types available for consideration. So the first one is your standard infrared. So this is where the sensor assembly emits an LED beam, usually infrared, to sense objects within its surroundings. It's basically just looking for a reflection. It can, however, be impacted by dark clothing, rough or dry textures, and the likes. And it's usually the one that if you wear a reflective vest into a washroom, all the faucets go off. It's using standard infrared. The next one is an optics technology which senses distance. So this is where it's using triangulation to not just sense presence or the presence of a light reflection, but how far something is. And then finally, we have capacitance-based sensing technology. So this doesn't use any visual sensing at all. What it's doing is it's actually emitting an electromagnetic field, a capacitance field, on the whole faucet body. And as your hand or other object moves into the vicinity of the faucet, it's disrupting that electromagnetic field, and that's what's actually setting off the faucet's solenoid. So this one is really interesting because it's not affected by dirt, debris, reflections, clothing, color, texture, anything like that, because it's not using a visual sensing technology at all. Another very important consideration is the prevention of scalding and thermal shock. Patient rooms and bathrooms have to be given a careful consideration, and engineers should take a systems approach when specifying the plumbing solutions for them. So temperature limiting valves can be incorporated into the system when predetermined maximum water temperature is a must to minimize the risk of scalding. ASSE 1070 mixing valves are standard for local mixing valves to limit hot water temperatures to 120 degrees Fahrenheit. These thermostatic mixing valves are installed near the point of use, and common applications include limiting temperatures at sinks and shampoo bowls, delivering tempered water to lavatories with or without automatic faucets, limiting hot water temperature to a specific side of a faucet or fixture. So if you have a two handle, for example, you might still want to put a mixing valve in there to make sure that somebody using just the hot water is not going to get scalded. And then alternatively, the ASSE 1069 valve delivers up to 120 degrees tempered water to serve shower rooms that utilize push button metering valves or automatic valves in a single temperature shower system. These valves are available from various manufacturers as point of use or supplying a bank of faucets. So just as something to point out here, these pre-plumbed boxes include the mixing valve in there, and in a lot of applications, if you have an electronic faucet, you can actually add the electronics in here as well. So you can also choose to use manual faucets. Spaces where you might want to consider manual over hands-free include memory care units, where residents function more intuitively with a faucet that has functioning handles. They might not be used to an electronic faucet at home. Several manufacturers provide a temperature limit stop to preset maximum temperatures as well on these manual faucets. If you are selecting a manual faucet for any part of your healthcare project, you'll want to consider whether you want to go with a single handle or a two handle product. The ADA requires that a person has to be able to turn on a faucet without twisting or straining and the wrist of the wrist and using less than 5 pounds of force. So the ability to activate the water flow easily with only one hand makes it simpler for people with physical limitations to turn on the water. The user shouldn't have to grip or pinch the handle with force in order to get the water to flow. So the examples that you see on the screen there, all of those are ADA compliant, where less than 5 pounds of force can be used to activate each of those levers. And they don't require any pinching or holding or anything like that. So you can use, you can use these for applications where they may be used by people with low turning strength or inability to pinch. So the flow of water is also an important consideration from a safety perspective. It's possible that when air is mixed with water, small droplets of infectious bacteria that might dwell in the piping can be released into the surrounding environment. This can affect the safety and health of high-risk patients, especially. A laminar flow where there's no air introduced into the water stream is crucial to avoid the spread of bacterial microbes and help ensure better hygiene operations in any environment. So over on the left side, you see, over on the right side, you see a laminar flow where there's no aeration, so there's no air being mixed into that. In some healthcare facilities, you also, in addition to having laminar flow, they are also required to have a smooth end, so no aerator at all, nothing on the outlet. So it's important to know what the application is. So somewhere like an operating room or a surgeon scrub up, you will need that smooth end laminar flow. So when you're selecting a sink drain for public spaces, it's important that you select some form of grid so that paper and other items don't slip down the sink. In settings particularly concerned with hygiene, hooded strainers that reduce the splashback are also available. So this might be something like a domed hood where it reduces the splashback. There are even automatic faucets with programmable flushes to ensure that drains are adequately rinsed to remove foul-smelling liquids and soap buildup. So, the same programmable flushes can also be used to clear stagnant water from supply lines at regular intervals. This is really important, especially in areas where you might not get frequent usage of the fixtures. And that stagnant water, even though water usually has some level of chlorine or chloramine to keep infections down, if it sits long enough, it will evaporate, it will get consumed, and you may have bacteria growing in those. So having a 24-hour flush or, once every few days is crucial to making sure that bacteria is not harbored in stagnant lines. So when you're selecting a flush valve for the toilet, you might also want to seek out one that has an adjustability feature to fine-tune how the bowl and valve work together to accommodate variations in water flow and pressure. So I touched on this a little bit earlier, but this can help minimize toilet plume or the dispersal of microscopic particles as a result of flushing the toilet. So you might have a bank of toilets almost next to each other that are using the same flush valve, and you might notice the one at the end doesn't get adequate volume, and the one at the start has a lot of splashback. In that case, you should be able to adjust the flush volume so that you can fine tune it for each individual toilet. In behavioral healthcare settings, consideration is also needed to be given to protect the vulnerable. So several plumbing manufacturers offer ligature-resistant products specifically designed to minimize the risk of injury to patients. They're designed to be vandal-resistant and prevent the attachment of ligatures while still giving the patient access to water. In addition to the shower area being ADA compliant, you should also consider how the staff and patients will be using the various shower areas in a healthcare setting. In most cases, the patient will either be partially or fully assisted by nursing staff, so ensuring that the shower mechanisms are easy to turn off and on is critical. And in addition, zero barriers so that wheelchairs can easily access the area is also important. Accessories such as grab bars and hand showers should be thought of in place not just for the patient, but also for the assistance and safety of the staff who will be using them. Finally, we also want to think about the ambiance and comfort in a healthcare environment. Creating pleasant surroundings can go a long way in easing the stress of the patient and the visitors. An attractively designed bathroom that veers away from looking too institutional can lend itself to an overall positive experience. There are numerous manufacturers who provide stylish but functional plumbing products that meet the rigorous requirements of the healthcare environment. Now let's talk a little bit about sustainability in plumbing. So healthcare organizations have a responsibility to safeguard patients, staff, and the community, and a strong sustainability program is a key part of that. Such a program entails reducing the organization's carbon footprint, making sure harmful substances don't get into landfills and water systems, and managing internal operations to conserve resources, such as reducing power and water use, for example. The types of plumbing products selected in any healthcare facility can help work towards those sustainability goals. If you're using electronic or hands-free faucets and flush valves, there are various options for how these products are powered, with some with better sustainability than others. So if you're looking at battery operated, these are best for locations that don't have any outlets nearby. They're relatively easy to install and recommended for use in low traffic applications. However, the batteries do need to be changed out from time to time. Solar energy harvesting with battery backup is another option. So this reduces battery replacement and costs. It transforms all light types, whether it's natural or artificial, to charge a capacitor within the faucet so that the battery is only used when the solar power is depleted. This is recommended for use in low to medium traffic applications. You also have turbine energy harvesting with a battery backup. So this functions similar to the solar powered faucet, but instead of using light, it uses the movement of water to generate energy, using the battery only when the turbine energy is depleted. The more that the faucet's used, the more turbine energy generated. And this is recommended for use in medium to high traffic applications. And then lastly, you have hardwired. So this can be either hardwired, adapter plug, or one of those with a battery backup. So here a power outlet is required. This option greatly reduces battery replacement and will be a more cost-effective option in terms of energy usage. And depending on the manufacturer, this power option allows for multiple faucets to be daisy chained or ganged together in close proximity. And this is of course recommended for use in any level of traffic from high to low. So just touching on that daisy chaining, it may be possible, depending on the manufacturer, to link or daisy chain electronic faucets. A daisy chain is a wiring scheme in which multiple devices are wired together. The benefit of this being that the installer only needs a single adapter for multiple faucets, and that provides an installation and overall material and cost savings. Not all manufacturers offer this ability, so be sure to check ahead of time to understand if this option is available and how many faucets can be chained together per adapter. So choosing the right aerator is an easy step in the fight for water savings. They come in a variety of gallons per minute levels from 2.2 to as low as 0.35, as I mentioned, and spray patterns that each have their own unique characteristics and need to be understood in order to get the correct flow and functionality. So depending on the nature of your healthcare project, there may be certain criteria that's required to be adhered to with respect to flow rate. So for example, UPC and IPC code for commercial faucets in public locations throughout North America requires a flow rate of 0.5 gallons per minute or 1.9 liters per minute. Now, there are exceptions to this code, but for LEED certified facilities, 0.35 gallons per minute is required to meet LEED's 4.0 and 4.1 guidelines. Um, so for healthcare applications, more water flow is typically needed to meet surgical scrub up requirements. And in many hospital applications, the aerated spray type can't be used as we talked about. Although aerated is the most popular spray type used elsewhere because it makes streams feel stronger while using less water by mixing it with air, it can't be used in hospital applications because introducing air into the faucet stream can potentially introduce airborne pathogens into the water, which may lead to Legionella disease. The type of aerator used in the faucet can help meet your goals. The range of spray patterns and flow rates available is just vast. So spray aeration produces a shower-like pattern when dispensing water. Needle spray aerators are the only choice when you're selecting an ultra-low flow faucet, for example, 0.5 gallons per minute or 0.35. Um, Technology is not yet available to produce an aerated or bubble stream for 0.5 gallons per minute or lower. So sprays a good option to provide good coverage of water, which works well in bathroom settings. An aerated flow, as we talked about, adds air to the water, and these are usually from 2.2 to about 0.35 gallons per minute. And then, as we discussed previously, laminar flow aerator produces a crystal clear stream of water, so no mixing of air and water. And room air, since it can contain bacteria when mixed with water, could potentially become contaminated. This is also the reason in many hospital settings, it has to be that smooth and laminar, where it doesn't have an aerator at the tip of the faucet. In the US, the law requires that manufacturers print A112.18.1M on aerators and shower heads sold in the US. They have to print that on every aerator in the US, so the number doesn't say anything about the size, style, or brand of your aerator. Instead, it's a number that simply indicates that the aerator complies with the applicable ASME standard. Now, on to maintenance. In healthcare, there's a demand for enhanced cleanliness and more effective maintenance, so hospital management can turn over the rooms faster and get them completely sanitized for the next patient. Reliable and easy to maintain plumbing systems are also the answer to costly hospital shutdowns that can result in the inability to provide patient care. And something as simple as a failing faucet could render a patient room no longer usable, or waiting for a valve replacement, which could mean shutting down an ICU, for example. As we mentioned earlier, easy to maintain systems that feature redundancy are key to success. Poorly maintained healthcare plumbing can hold dangerous bacteria, which can harm patients, visitors, and staff. And regularly scheduled cleaning and maintenance helps to protect those patients, staff, and visitors inside the healthcare facility. A common way that bacteria forms is through lukewarm water, as it thrives in water that ranges from about 77 to 113 degrees Fahrenheit, making it a potential breeding ground for bacteria. Another situation ideal for bacteria growth are the use of low flow plumbing fixtures due to slower moving distribution piping runs. And water that is stagnant within a piping system runs the risk of having disinfectant dissipate. So, for example, chlorine or chloramine, and that invites the potential growth of Legionella bacteria. A facility manager's inability or ability to fully eliminate the risks of this bacteria has a lot to do with proper system design and water management. Maintenance schedules can't be ignored, and it's possible this can happen during staff turnover, especially. The best way to eliminate Legionella bacteria is for facility managers to have a multi-barrier systems approach and water management plan. Its key facets include higher storage temperatures with ASSE 1017, so that's 1017 thermostatic valve protection, and proper distribution temperatures driven by Legionella mitigations guidelines with ASSE 1016, 1069, and 1070 thermostatic valves at all points of use. In addition, facility hot water sanitation has to include or may include ultraviolet treatment, point of entry and point of use filtration, and treatment regimens like copper silver ionization and chlorination. With the growing popularity of digital mixing stations, hot water purging and mitigation protocols can also be met more easily. So a digital mixing valve system can send highly heated water throughout the piping at all points of use. Typically, this is accomplished in a facility with a very deliberate design, zone by zone, to assure thorough sanitation and safety. Where digital mixing systems can't be used, some manufacturers provide a mechanism like a switch that gives the ability to override the electronics on a particular faucet. So it's designed so healthcare facilities can continue to follow infectious control procedures at the point of use. When you're using the switch, the staff can manually run an electronic or metered faucet for an extended period of time at high temperature for thermal sterilization. It's usually installed as a single three-position switch per faucet. Cleaning protocols in a healthcare environment are paramount. So both the CDC in the US and the Canadian Public Health Agency in Canada, with support from National Advisory Committee on Infection Prevention and Control, or the NAC-IPC, have guidelines on how to prevent the spread of infections. In healthcare facilities, specific cleaning products are used to ensure a high level of hygiene and infection control. So it's important to ensure that you select plumbing products that have been tested to withstand the harshness of hospital-grade disinfectants, not only on the surface, but also on the inner workings. So it's essential that the electronic elements have been properly sealed so that the chemicals do not affect the faucet's performance. So one, if you recall, there are three different type of sensing technologies. One of the benefits of a capacitance type of technology is that there are no exposed electronics above deck. So you can use those harsher chemicals without worrying about damaging the electronics or the lens. Preventative maintenance is amplified for healthcare plumbing systems given the heavy fixture use and lengthy operating hours. Catching maintenance issues promptly preserves the integrity of the plumbing system, and lack of maintenance speeds up the deterioration. When selecting plumbing products, it's important that you think long term on behalf of your clients. So, how easy will it be for maintenance staff to shut off the products for servicing? How often will parts, including batteries, need to be replaced? And how easy will it be for staff to get the parts they need to repair something should it go wrong? Finally, how responsive is the manufacturer when joint problem solving is required, whether remotely or on site? Working with reputable manufacturers with experience in the healthcare field would certainly be a benefit to all. Now, this concludes the course, so let's review a few of the highlights. So first, product selectors should meet all industry standards to ensure there are no surprises when inspectors come to review your work. All current local, provincial, state, and national buildings and facilities and plumbing standards and codes need to be considered carefully when products are being specified. So keep in mind, you do need to get in touch with your AHJ or authority having jurisdiction entity to make sure that you're building to the standards that they are going to be inspecting to. Your end user safety should be considered the number one priority. It's essential that products are selected as part of a continuous system that all work in harmony to meet the project goals. And then finally, the project should be thought through with goals and the true cost in mind, not just the upfront cost. So with that, we are right on time, and I will wrap up this session and hand it back to Zach.
Yeah, fantastic. Thanks for putting that together. I think there was not just, there was a lot of great detail, but it was also very diverse in what you covered. You don't often see, coverage of things from like the AHJ to the flow rate to the operation. So thank you for that detail. One question
Absolutely.
I saw come in from the chat was on the laminar flow and the various flow rates aspect. Obviously, you mentioned that conversation that needs to be had between whether it's water sense or the IPAC
Yeah.
level. And in actuality, what are you finding in terms of effectiveness, feedback from the healthcare teams for, say, 1.0 laminar, 0.5 laminar?
So in healthcare facilities, by far, the most common flow rate that we're asked about is 1.5 gallons per minute. And that seems to be the balance between enough water to make sure that you have a thorough clean, but not too much that you're wasting water. What we find is in healthcare facilities specifically, they avoid the ultra low flow, especially on surgeon scrub ups and areas where doctors are working,
Hmm.
because they need that thorough cleaning really quickly. They need that full coverage. So 1.5 is the industry standard for healthcare facilities. We do often get, of course, more than that, but typically I haven't really gotten a lot 1.0 or below.
Okay, great. And I don't see any other questions coming in, so let me bring up the spec tool here that we referenced earlier. One of the things that we mentioned at the top of the hour here was, all of these sessions are recorded. So of course you have the ability to manage, your time and come back and review the previously recorded sessions. And you can do that right on the atspec.com website. If you go to the Architects and Engineers tab, you can go to the Learning Hub and find all the previously recorded sessions. So if you missed anything today, if you want to go back and reference maybe that flow chart breakdown, which is a great piece that Ranveer put together, then you can do so right there in the webinar recordings. And of course, if you have any questions on the things covered today, you want to get into a deep dive on any particular aspect, feel free to reach out to myself, my team, and we will organize that conversation with Ranveer and the Delta Squad. Again, if this is your first time joining an ATS University, this is our online recording session where we kind of do like an ATS version of a lunch and learn, where we cover one of the many manufacturers that are available on the ATS spec tool. If you haven't seen the spec tool before, it's where you combine, I think it's at, I counted it up while we were doing like the intro on the presentation. I think it's 44 different manufacturers now directly on the ATS spec tool. And then, groups like Delta that are on the overall ATS spec tool. They also have their own white label version that you can access directly on their own website. All of these are available for free for engineers, design build contractors, architects, interior designers, anyone that wants to make an accurate selection. So, one of the differences that we always highlight, let's use the flow rate reference. The flow rate that you select is going to affect your model number. And in the ATS spec tool or any of our white labels, you are going to select that flow rate and configure your actual selection so you don't just get a generic model number that you need to fill out or have a contractor guess at down the line. You get the accurate selection that meets your project's requirements. And that can be done, quick and easily from deltafaucet.ca. You go to the commercial tab, to the spec select tab here, and that will bring open your Delta commercial spec select. You can see I'm logged into the demo account here. You can see this is a heavily used demo account. We've got a lot of projects, quick specs, and total products specified there. But really, the engine of it is here in your quick actions tab. This is where you create quick specs, projects, and masters. They're really just varying degrees of folders that have different levels of rules associated with them. The entire system is a rules-based database, is the way that we explain it. So something as simple as a 4-inch center set basin has a 4-inch center set faucet. We prevent that sort of confliction that can affect change notices on your project site. And a quick spec is going to have very minimal rules. It's just your title. You would simply go in, search for a flush valve or a faucet, and make a quick selection. So you can see I've got all these different tiles here of all these different product types that Delta has available. I'd go into the flush valve category. I could filter by water consumption. So let's say we want an ultra low flow 1.1 or 4.2. Let's say we want to switch this over to sensor operated like we talked about, or even get more refined with, say, solar powered or hardwired. You can see then we've got our exposed, our concealed in-wall, and our in-wall power sensor. And then you can, open up the card, see the additional configuration options. In this case, because we've already filtered it, it's already selected. But if I wanted to change that flow rate, I would just hit my reset, make my new selection. Let's go with the 12 by 12 box. And it's going to update our model number, update our list price every single time we make a selection. If you just want, the manufacturer's spec sheet, that's available on most manufacturers' websites. In this case, it's also embedded into the system. But if you are looking for a configured selection that matches your actual choices for a product, then, the ATS spec tool and Delta spec select is a great way to help you get exactly what you need on your project. You can see it's recommending the hardwired transformer here, anything else in what we call the fixture chain that's required. As we're within just the Delta version, we see just the Delta product. And then if we wanted to see the whole suite of ATS manufacturers, then that'd be available on the ATS spec tool. So similar process, you would log in, you can see, so there's some similarities in the background here. We are advertising our ATS University up here at the top, where you'll see, next week's webinar coming up in a few hours. You can see the same rules engine database for our quick actions bar here with the quick spec projects and masters. We covered what the quick spec was, but a project is just that next level of detail. This is where you're going to add a location. And just like Ranveer discussed in the presentation, your location's affecting your AHJ and your location's affecting the code that you're building to. So does your application. So you select your location and your application, and then our rules-based database will start making smart recommendations. Then we have that ultra level of detail in our masters, which allows you as a firm to basically set your preferences. What are the preferred toilets, basins, faucets, flush valves for a healthcare facility versus your preferred, similar fixtures, drainage, water heaters, et cetera, for an office building. There's going to be differences. And you, as the admin of your account or a team lead for your account, if you have a board of 5 that sit around and confirm your master every year, then it's be great to work with you, help you set up your masters to reflect what you have internally already. We'll build it on here so that your team has the ability to use our new feature called our Masters Quick Access Drawer, where you can see I've got a bunch of products selected in here already. But if this was blank, I could build this same thing in seconds using our Quick Access Drawer. And this is where you can use your masters. You can use the ATS templates to very quickly drag and drop from your approved selections that your team has worked on. So you can see this could be any of your internal masters. Then we have our ATS templates, which is like our versions of those masters. And you could go in and say, yes, I need all these, but there's no bariatric suite on this project. We're doing wall hung labs only, so I don't need the drop-in labs, and we don't have any double bowls. No problem. Done. Drag and drop. And your EIT that starts next week, if it's your first healthcare project in a while, you can come back to Zach's engineering firm Healthcare Master and know that this is going to be up to date and current. There's no discontinuances. We're going to reach out to you if there's any sort of change to a model number, or let's say there's been a major discontinuance and you need a new selection. Our team's going to help you keep this up to date and accurate. Additionally, we can have all your approved alternates in here, so you don't need to go to 3 different websites just to get the appropriate information. We can help you keep all your masters up to date, and then all your team is working on approved selections. This is especially great if you are specialized in a healthcare application. Sometimes different owner groups may have different preferences. When we get into, say, hand hygiene sinks or your surgeon scrub sinks, some owner groups for your healthcare, maybe they prefer the knee activation, and then others prefer the sensor activation. Even within my local area here, there's one hospital group in Toronto that is all manual, and then across the street is another hospital group that they've gone all sensor operated for the last 15 years. So you can set your preferences, quickly drag and drop, not just from your fixtures, but from scrub sinks, plaster sinks, drainage, mechanical equipment, fire protection, piping, some HVAC product. If you're on the architectural side, all your partitions, grab bars, soap dispensers, etc. All of that's available on the system here. So really, it's add whatever fits your niche. Let us help you stay up to date and accurate. And then when you need to download it, you just check the box, hit generate spec docs, and you can go through, select your submittals, schedules, 3 different types of written specs. One of these written specs is going to fit how your firm goes to market. Of course, the Revit files, manufacturer spec sheets, and even a nice product brochure package. And I always assume that I'm going to be a little bit late. I see we're at 1 o'clock here, so it's giving me 30 seconds to show you the configured selection. Combining multiple names and numbers all onto one page, showing the list price and all the information. Again, you're getting the actual model name and number that matches your selection, not the generic deselected version. That's one format. You can see the additional equipment here, backflow, floor drains, etc. Get into your schedules in Excel, which all of our formats are open and editable. You can copy and paste this directly onto your drawings. You can go to the fixture schedule as well. Let's show that the Delta commercial with the -CV selection in there. And then, of course, our written specs. So this is the CSI format. You get a nice clear description, model name and number, and then of course you're going to have all approved alternates as well. We've got our long spec in Word. Same information. All ATS is really doing is managing data and then allowing, various configurations. So if there's another format you need, let us know. We'll try to develop it over the next few months and have that available in the market. And then, of course, we've got, I think I downloaded the short spec as well. No, but the Revit files, which I don't have Revit on my laptop here, but I would just download as a zip folder, different product groups in different formats, nice and easy to access and ready to use. So that's the really quick version of the introduction to the ATS spec tool. If you like a deeper dive, let me know. We can show you how you can make your selections, set your standards for your masters, and keep your entire organization a little bit more organized and accurate. And then simply save on time by dragging and dropping from stuff that you know is up to date and current. So that's the very quick intro there. If you have any further questions, feel free to reach out to us. We will have your certificates out by the end of the week. I appreciate you all taking your time with us today. Hopefully you learned something about the healthcare industry and the product selections for it. And of course, Ranveer, thank you very much for your time. That was a great presentation. Looking forward to the next one.
Thank you, Zach.
Bye, y'all.
Bye-bye.
Thanks for joining us. Have a great day.